Review problem set for derivatives number 5 starts with kind of a banger because I never remember the derivatives of trig. And you shouldn't have to remember the derivative of cotangent. You just need to know how to find it quickly because when you're on a test, you don't want to mess around. This is clearly a quotient rule if I want to take its derivative, so that'd be u prime v minus v prime u over v squared. And what do I want to do with that? Well, we can write it out. It's actually pretty simple. U prime is negative sine, times v is sine, minus v prime is cosine, times u is cosine, over sine squared. So you're going to get negative sine squared plus cosine squared is negative 1 over sine squared. So that is very quickly found to be negative cosecant squared of x. So let's just write that real quick. d dx of cotangent equals negative cosecant squared. Just keep that note there. That's all you need to do in the middle of the test is just remind yourself of these things. But you're probably on your final, especially in Calc 1, going to be asked to derive these. So I wouldn't be surprised. Let's do it for cosecant also, which is the same as saying 1 over sine. That way we can solve this quickly. Again, you can use the quotient rule. No tricks, just a simple trick. U prime is 0, so this is just out for this guy. You get negative cosine v prime times 1 over sine squared. So that's going to be cotangent times cosecant. Cotangent takes up 1 of the sine on bottom, and then you have 1 over sine. That's the cosecant. So d dx of cosecant is equal to cotangent times cosecant. And is it negative? It is negative. Yeah. So we should be good there. Okay, let's do the actual problem now. That's the fun part. Y equals cotangent of cosecant of x. Man, my handwriting's bad today. I think I'm a little shaky. My blood sugar's probably low. Look at that y. That's not even a y. It's like a, I don't know what it is. Y prime equals, what's the derivative of cotangent? We just found it. Negative cosecant squared of the input, which is cosecant of x. This is not cosecant cubed or anything like that. It's a function inside a function, times the derivative of the inside, basic chain rule, negative cotangent of x times cosecant of x. So the negatives cancel out, and I think what we get is, to write it the fun way, cotangent of x, cosecant of x, cosecant squared of cosecant of x. And that is actually the correct answer for this problem. Pay no attention to this dot. That was just some kind of writing error there. But yeah, I think that's the actual derivative for this problem. So that's pretty dang ugly. Maybe it simplifies in some way, but I don't see it. What about the next one? The next one has a secant in it. Let's just find the derivative of that real quickly because I don't want to stop in the middle. So secant is 1 over cosine. His derivative will be quotient rule again. Get used to doing this for trig functions so you can find answers quickly. U prime is 0, so this is just gone. And you get a negative v prime, which makes it a positive sine of x, times 1 over cosine squared of x. So we're going to get tangent of x for sine over cosine, and then 1 over cosine is secant of x. So we'll write it over here just to have it. d dx of secant of x equals secant tangent. Maybe you have that memorized, maybe you don't. I don't memorize things because I'm busy memorizing how to derive these things. And you should be focusing on that too. That's the entire point of calculus, is to know how to get there. Okay, let's see what we get here. Y equals e to the x secant x. This is a cool problem. So y prime, well, the derivative is going to be the same thing. x secant x. Except there's a chain rule. Don't you just hate the chain rule? And the chain rule says we need the derivative of the inside function, which is the exponent in this case, and that is two functions of x multiplied, which means we're going to do a u prime v plus v prime u. Well, what's u prime? That's 1. Thank goodness for that. V is secant of x plus v prime, which is tangent x secant x times u. What's u? That's x. So we're going to get, I think we can write this in a cool way. Y prime is equal to e to the x secant x times, let's see if I can do it this way, times secant of x 1 plus x tangent of x. The beauty of that algebraic pullout, factoring, makes it just so lovely. Doesn't that just look great? Maybe I'm a little bit romantic for calculus. I admit it. There is a reason I chose it as my first course. But look at that derivative, and you can absolutely do that. And if you did do that, I hope you leave a comment and let me know that you got there, because this is the essence of finding derivatives. I'm going to leave the secant part up because that next problem includes one, so we might as well just leave it there since we learned it already once. I have to learn it 1,000 times, and even then I probably won't memorize it, but y equals secant of 1 plus x squared. Well, y prime, we already know the derivative of secant thanks to our prior work. Instead of looking at a cheat sheet, is this, except one problem. That's not what the input was. It's going to be tangent of 1 plus x squared, secant of 1 plus x squared, times derivative of the inside. What's that? Power rule, 2x. I think that's all this one takes. Just be careful to remember that when this x is shown to you, that's the input. It's not an x. It's the input. Whatever the input is, in this case 1 plus x squared transfers right in there. Okay, I think that one's done. We could write it by putting the 2x in front, but it's the same thing. That's that one. For the last question, I think the first thing we want to do is rewrite the idea as x plus x to the 1/2 to the negative 1/3. I'm sure you can see why I would want to write it that way instead of in radical form. So if I want to do y prime, we get negative 1/3 x plus x to the 1/2 to the negative what? Subtract 1, what do you get? Negative 4/3 times the derivative of the inside, which would be 1 plus 1/2 x to the negative 1/2. And I think this can probably be simplified if we actually work it out, and I'm afraid to do it. So maybe let's tackle this one first. So that's 1 plus 1 over 2 rad x. So what I'll do is I'll take this 1 away, and I'm going to make it 2 rad x over 2 rad x, and we'll get 1 plus 2 rad x over 2 rad x for this one. And this is negative 1 over 3 cube root of x plus rad x, like that, times this. So we're going to get what together? What's going to come together here? Here's our negative 1. Do I really want to FOIL it out, though? I don't know if I want to do that. I do not know if we want to do that. So what I'll do is I'll write it like this. I'll write it as negative 1 plus 2 rad x over 6 rad x cube root of x plus rad x. And this is to the 4th, like that. That should be the right answer. Yucky. Yucky, yucky. But that is the right answer. So calculus isn't always sexy, but it is correct. And I hope you got the answer. If you worked this one out, put it in the comments because you deserve a +1 to you, sir, or ma'am.